All right. Hello, everybody, again. Let's get started. I'm going to start by moving all of my stuff out of the way. All right. Can everybody see my screen? Yes? Perfect.
Yes.
Awesome. All right. So today we're going to be talking about scraping in Ruby. Again, we're going to start out very generally, and then we're going to move in on the specifics and what tools we're going to be using. So let's get started. First of all, who can tell me what HTTP GET requests are, or what HTTP is?
Hypertext Transfer Protocol.
Correct. Nice. And what is that? What is it in like plain English? What's HTTP? And what are GET requests? Anybody?
Well, I imagine a GET request is when you, when via the Hypertext Transfer Protocol, you send something to, you send a request from a server to be brought up onto your computer.
Yeah, exactly, right? So really, Hypertext Transfer Protocol is a fancy way of saying, hey, these are some rules that allow us to standardize communication between, anybody's computer and a server that hosts a website, right? That's what protocol is. Protocol is a set of rules. Hypertext is the HTML that comes back that kind of it gives structure to the information and the text that you're getting back. And then transfer, obviously, is just the process of transferring it from the server hosting to your computer at home. So it's a lot less scary than Hypertext Transfer Protocol sounds, but good job knowing that. That's awesome. And you're completely right. GET request is just, so there are a few things you can do over HTTP, and GET request is the most basic one. It's the one we're going to focus on today, and we'll branch out in the future and talk about some other things that we can do. But today we're just going to talk about GET requests. So what happens when you load a web page in the browser? Well, I kind of already gave the answer away. The answer is you send a GET request to the server. And I had this nice little drawing down here, and it shows a little picture of what that might look like, right? So you have your computer on your desk here, and you have another computer off somewhere in another state or another country that hosts the website. And you're here. If you put your magnifying glass in on the wire here, you're going to see your little GET request that's being sent to that server, and and you're asking via the protocol or the set of rules for information. So our computer outputs a series of electrical or light or EM wave signals, right? So electrical or light would be like a fiber, and EM wave would be like if you're over Wi-Fi. And these signals represent a request for information, and they follow a specific set of rules, which is what we just talked about. And we kind of already covered GET requests. And so when the server gets this specific request, because it's following the set of rules that embody a GET request, the server is going to know how to respond. And if it's a correct request, it's going to respond with HTML and CSS. So can anybody tell me what HTML is?
Hypertext Transfer Language. Hypertext Markup Language.
Yes. Okay.
Oh,
and
sorry, I wasn't on mute.
You're good. No, you're completely right. And so what does that mean? Like, so what is it for? What's the purpose of HTML?
Retrieves and arranges the it's instructions to retrieve like bits of code and small programs and stuff, as well as how to arrange it on a web page that's requested.
Yeah, you're right about arranging, but in terms of like retrieving other stuff and other instructions, that's going to be done mostly via JavaScript. HTML is a it's a markup language, like the name suggests, and it tells your browser the structure of which the data that comes back is in, right? And it basically tells your browser how to display it along with CSS. And CSS is styling, HTML is structure. So let's say I have an H1 tag in HTML. That tells my browser to make it a big header, right? As opposed to CSS, which is where you're going to define like location on the page, colors, whether you have a border around it, stuff like that. All right, and like we just said, CSS is a style sheet language, which means it tells the web page, the style of how it should display, as opposed to HTML, which is more the structure. All right, so let's take a look at what this actually looks like. So if we look on the left-hand side, we're just seeing a random Google Chrome Google that I did on recursion, which has a nice little Easter egg here. So recursion is when a method calls itself. So if you type in recursion to Google, it'll say, did you mean recursion? In which case it will also, again, search for recursion, which in itself is recursive. So it's a little fun fact. Anyway, so you see the web page on the left, which is how Google Chrome or whatever browser you want to use displays it to your eye. And then on the right is what the HTML actually looks like. And as you can see, I have all these divs in here, some A's, I's, right? So what this is telling me the structure of what I want to be seeing on the left. So an A is a link, right? So as you can see, we can see recursion right here, and that's inside of our A tag, which has an href, right? So our href is the URL that we're going to be taken to if we click the link. So HTML, as you can see, is just this way of telling the web page how to display the way that we want it to display. So if we want a link that says recursion, and if you click it, it goes to the site, we put our A tag here, we put our recursion text inside, and then we make the href equal to wherever we want to go. Make sense so far? Yeah?
Yes.
Awesome. All right, so what does this mean for us as scrapers right now? Well, our goal for us when we scrape is to get information from a web page and then filter and transform it into our own app and then utilize that information. So this is really great for us because we know that we can now perform an HTTP GET request and we can now get back information, which is text, in the form of HTML, like we see right here, right? So this is awesome. So now we can take this text as HTML and we can parse it and get all the information that we want. So what do we need to know how to do this successfully? Well, first of all, how do we execute a GET request? That's important, right? Because if we can't execute a GET request, we can't get the HTML. How can we parse the HTML effectively to retrieve only the pertinent information that we want, right? So this first step we're going to be calling harvesting, actually getting the HTML from our GET request. This next step is going to be called filtering. And again, these are terms I made up. These aren't like official word terms, so you don't have to like memorize them, but it's a really good way to kind of break down the steps. So the filtering part is actually quite difficult because again, let's look back at what we're working with. Like this is not something simple to parse and to find what we want. It looks like kind of a mess. And when we talk about larger websites, we're talking about you know, thousands, possibly thousands of lines of HTML to parse through. So that's not super easy. So we'll talk about how we can do that effectively. And then we want to, once we filter down the HTML to the actual information that we want to then transform it into a useful Ruby data type. So for example, we'll make a class that can hold the information that we're getting. So once we filter, we'll probably end up with something like an array or some sort of hash-like thing, and then we want to turn that into a class. And then finally, we're going to be making an ecosystem of classes that now let us use that information in a sort of application environment. And we're going to be calling that utilize. So let's take a look at an example. We have a job. We've been hired by Ollivander to be his assistant on Diagon Alley. And he needs us to create a spell that writes down random combinations of wand cores, wand woods, and wand lengths so he can make them for new wizardling and witchlings, but not younglings because they've all been killed by Anakin Skywalker. So the problem is, though, is that you lied on your resume and you have no idea what woods or cores go into wands, and you're also a squib, so you can't perform magic. So we have to rely on our scraping abilities and our basic knowledge that wands are usually 9 to 14 inches to not get fired. So let's take a look and see how we can make this happen. So the first step, if we remember, is harvesting the HTML. So let's first find out where the information lives that we want to harvest. That's always going to be the first step. So let's take a look at this site right here. And that's going to be right here. And this is Wand Woods on Pottermore by J.K. Rowling. So it turns out that this has a lot of woods that go into wands as well as the description of them. So this is pretty great. All right, and then the other thing we want to look at, oops, sorry about that. The other thing we want to look at is wand cores, which is going to be this page right here, which has the 3 cores that can go into a wand and then description of those. So this has the information that we need. How do we get the HTML? So there are a few tools that we can use to do this. HTTP Party is really cool, but today we're going to use OpenURI, which is built into Ruby, and it allows us to do a GET request very, very easily. It's a very abstract way to do it, which is nice. So let's take a look at what that looks like. So all we have to do is we define the URL as a string, and then we just say open URL. This will return an instance of a temp file class. So open URL is going to let us do GET requests as if we're opening a file on our computer. So when we say open URL, it'll go to that URL, right? It'll do the GET request, and then it will have a temp file class, which we can then read and turn into a string, which will be HTML text.
But we have to require OpenURI before, right, at the top of our file.
Yes, we do. And I'm about to show you an example of that.
Cool.
Cool. So let's take a look at what that looks like. What is happening? There we go. All right. Can everybody see this okay? Yes? All right. Awesome. So like you said, require OpenURI is necessary. And then we just define our base URL, right? Because there are two things we wanted. We wanted to grab this information and this information. And if we look at the URLs, let me move my zoom bar over so I can see. If we look at the URLs, we can see they're very similar. It's just this last word's changing. So what I'm going to do is I'm going to define a base URL, and then I'm going to define a Woods URL and a core URL. And right now, just to kind of get the feel for it, we're just going to do Woods. So let's take a look at what this looks like. Oh. All right, so this is good. When we said puts read, we got all of this information back. That's the first thing we wanted to check to make sure that we were actually getting the HTML, which is very, very clear that we are, right? So that's a good thing. Now let's take a look at some of the other stuff. Let's get rid of page.read and take a look at some of this other information. All right, so as I said, when we output page.class, we're going to get temp file, just as if we're opening a file on our computer. The content type of the page is another method that this temp file has, and we can see that it's text/HTML, which is perfect. And then we can see when we say page.read, we can call .class on that and see that the data we're getting back is a string, which is awesome because we can do a lot of stuff with strings. Cool. So that's really all there is to it. We just say page, once we open the page with open and put in the URL, all we then have to do is just say page.read, and we have the string now saved in a local variable. So harvesting is actually not that bad. So let's move on to filtering. All right, so this one is probably a little bit more formidable, right? So now we have this string with all this HTML in it, and the question is, how do we get only the stuff that we want from this? Well, yeah, exactly, right? So the answer is that somebody's already figured this out, and there's this really, really cool gem called Nokogiri that is built to parse HTML for us, and it also parses XML, but we're obviously going to be using HTML for the most part here. And a really good way to do this is by using CSS selectors. So how much do you guys remember about CSS selectors? Anybody have any information on CSS selectors? Anybody remember anything, like what they are?
Yeah, it's how you address or how you want to dress up like your paragraph, or make it bold, highlighted, the margins and so forth.
Yeah, but specifically, what are they used for, especially in this context?
Separating the, I guess the P classes, the paragraphs.
It's really for finding what we want to find, right? So let's take a quick second to look at some of the HTML in
target the HTML elements on our web pages.
Exactly.
That we want to style.
Exactly. So notice how this div has a class. So we can actually get a hold of this div by specifying the div with this class, and then we'll get all the divs that have the class that we specify here. We can also use just the element itself. If we want to get all p tags, that's a CSS selector, just saying p. All right, so it allows us to grab information on the page based off of aspects of the HTML, right? So it's class, it's element type, and then a whole bunch of other stuff too that we'll talk about. And we're not going to go too deep into CSS selectors. So if you do feel like you want to get more practice with that, I have some good references for you. Specifically, there's this one game that's really fun that'll get you good at CSS selectors. It's the Diner, CSS Diner. I've posted links of it before, but it'll also be on this slide. So when I post the slide links, you'll have access to it. All right, so CSS selectors allow us to specify a portion of the HTML based off of the type. Like I said, if you want links, you'd use A for the A tag. The class, you can delineate what class you want by using the dot. So if I wanted a link, all links with the class of important, I would say a dot important. I can do an ID. So usually ID should just be one element. So if you wanted a link with an ID of super secret, you would say A and then hashtag super secret, and that specifies an ID. And you can also do this. I could not have the A here or not have the A here, and then I would get everything with the class of important or everything with the ID of super secret. You can also base your CSS selectors off of hierarchy. So if I wanted to get all p tags inside of a div with a class of tsinfo, the selector for that would be div.tsinfo. So that's specifying a div with the class of tsinfo. And then I would do a space and p. So the space p says, hey, all p's, which are children of this div. So that's really, really powerful. And that's going to be probably the, I don't want to say the most important, but a very, very important part of us using CSS selectors is going to be the hierarchy of the page and how we can utilize that to grab what we want. All right, so I have two links here, a little fun read on CSS selectors, as well as that game I was telling you about. That's a lot of fun and very useful. And then this is a deep dive into Nokogiri. So when you guys come back, if you want to look at the slides again, just go ahead and open this up if you want to deep dive into Nokogiri, and that could be a lot of fun. All right, so let's look at my filtering example now. All right, so here's our harvest in just a few steps without all our put stuff. So again, we're defining our base URL. We're getting our Woods and Core URL just by adding Woods and Core to the end of our base. We're opening up both URLs, reading both URLs. So now we have the HTML text saved in two local variables, Woods HTML and Core's HTML. So what we want to do now is turn them into Nokogiri. And again, just to requiring Nokogiri at the top here so I can use it. Now I want to turn these into Nokogiri objects, right? So Nokogiri is what's actually going to be parsing this for me. So I need to use it. So let's go ahead and take a look at what the class looks like. And if you notice, this is taking a little bit longer because I'm grabbing two things now over the network as well as parsing it. So the class is a Nokogiri HTML document. So this isn't just some sort of like raw Ruby class. So now I have this object that I need to know how to work with to grab what I want. So let's look at some ways I can do that. Let's comment this out. So here's how I can use my CSS selectors. There's a really cool method in these Nokogiri's HTML document objects called CSS, and I can call that method and then just put my selector in quotations. So let's take a look at why I chose these selectors. So this is a really, really important part of scraping. This is where we go to our website, we take a look at what the HTML looks like, and then we figure out how to grab what we want to get. So let's take a look at this side to side. It's kind of small. You know what I'm going to do? I'm going to make this full for now. Can everybody see this okay? Yeah? All right, cool. So let's take a look at the way that this website is structured. So it looks like I got here are all, I'm looking at this. I see all these H2s with all of my wood types. So I definitely know I need to grab all of those. And then it looks like the P tag right underneath is the description of that wood type. So now I need to ask myself, okay, how do I get just these woods that I need and then just the descriptions that I need? Well, they're inside of this div. So I have all this other stuff up here that I really don't care about right now. So they're inside of this div, and the div has a class JKR tech writing tech artifact _ text. And then inside of that div is where all these H2s live and all these Ps live. So let's utilize that in our code. So if you look at my selector, I'm saying, okay, I want something with a class of what I just said, and then I want the H2 descendants of this class. So if you see, I'm finding this class, JKR writing artifact _ text, and then I'm getting all H2 descendants, right? So everybody see why I'm using that CSS selector there? Anybody not see? Okay, cool. And then for wood descriptions, so that gives me the wood types, right? So I'm grabbing the H2s, which are the wood types. Now I need to get the wood descriptions. So I'm using this little fun guy right here. And what this is saying is, okay, so I want to look in the same div that has this class. And again, just to be clear, I could have said div dot. I didn't need to because there wasn't anything else with that class, so I wasn't worried about it. But you could be more explicit if you'd like to. Anyway, so now I'm like, okay, well, I don't want just all P tags inside of this, right? Because I have this P tag right here. I don't really care about this. I don't care about Mr. Ollivander introduces his notes. That doesn't bother me. So what I want to do is actually get all Ps that are directly after H2s. And it turns out this little squiggly guy does it for me. So again, this is one of those things where Google's your friend, right? I didn't necessarily remember how to do this right away, but it took me 2 seconds to Google it, and then I figured it out. So that's going to be a big part of this project coming up. And a big part of scraping in general is using Google, using that CSS selector game and getting your selector game up to par, and then that will allow you to Google effectively and be able to implement what you find. So anyway, what I'm doing here again is I'm getting this div with this class, and I'm getting all Ps that follow the H2s, which makes sense because all of my descriptions directly follow the H2. All right. Does everybody see how I looked at the structure of this page and got a proper CSS selector for both of those? Any questions about those? Cool. All right. So let's take a look at what we get when I do these 2 lines of code. So what I'm doing is I'm looking at my wood types, and then I want to look at the length of both my wood types and wood descriptions, right? Because I'm expecting a 1-to-1 match between these, because I should be getting one description for each wood type, right? So this is a way for me to test to make sure I'm getting what I think I'm getting. And again, this is another big part of scraping, is it's a lot of playing around. So you get the HTML, you mess with it, you try to filter the way that you want. So this file that you see right here, this is when I make a project, even if it's object oriented, I kind of start out doing something like this, where I just get into a file, I start messing around until I get the code which gets me what I want. And then we're going to talk later about how to put it into an object oriented paradigm. So let's see what we get when we run this. So awesome. So I put wood types, and it looks like I'm starting with Acadia, and I'm going all the way to U. So let's look at this. I got Acadia up top, and at the very, very bottom, I have U. Perfect. Awesome. And then another great piece of news is that my wood types length and my wood descriptions length are both 38. So that's a pretty good indication that everything is working out fine. But just to be sure, let's go ahead and grab a random index and make sure the description matches the wand. So I get hornbeam here for wood types, and then it says my own wand is made of hornbeam. So clearly the description is matching it. So now I have a pretty good idea that I am getting all the wood types, I'm getting all the descriptions, and that they are in order the way I expect them to be. Does it make sense so far? Yeah? Sound good? Cool, cool, cool. All right. So now I want to do the same thing with cores. So cores are a little bit different. They're a little bit more, they're a little bit tougher actually, because if we look at cores, we see that we get our H2s here, Unicorn, Dragon, and Phoenix. But the problem is they have 2 Ps underneath them. And each of them are description. Say I've got 2 Ps that are describing Dragon, 2 Ps that are describing Unicorn. So this is where you have to be a little bit more inventive. So, sorry, my headset keeps going out on me. So if I put these guys out, let's take a look at what we see here. All right, so I'm going to go ahead and comment out the description because clearly we're getting them. So let's put out the length of both the, actually, let's put out the length of the descriptions and see what we're getting. We should be getting 6, right? Because there's 2 for each one. So now what I need to do is find out how to, and this is another hard part of scraping, is when the website doesn't display things in a super easy way for you to use it in your program, because that's not what they're trying to do anyway, is we have to figure out a way to turn it into something that we need, right? So we need to somehow get our 6 paragraphs and combine them. So we need to combine the unicorn ones and combine the dragon ones. Well, I know that they're in order, right? So I know that there's a structure that I can use to do this appropriately. So I'm going to show you like a really advanced way to do it, and then I'll show you a different way to do it. The way I did it was I used each with index and then called reduce on that, which gives me a really, really cool little local variable set with a memoization, as well as the 2 local variables from each with index, so the element and the index. And then what I'm doing here is I'm saying if the index is even, I'm going to go ahead and shovel the paragraph in with the previous paragraph. But if it's, sorry, it keeps bobbing back to the left there. But if it's not even, so if it's odd, sorry, if it's even, I'm going to shovel it in as a new piece in the array. If it is odd, I'm going to go ahead and just add it to the previous one, right? So what that's doing is saying, okay, so 0 is considered even. So the very first one's even, so I'm shoveling it into the array. The next one is index 1. This one's odd. So what I'm doing is I'm adding it to this one. And then now I'm back to 2, which is even. So now I'm shoveling in this one. So this is now my index 1 of my final array. And now this is here is 3, which is odd. So now I'm adding it to this one. So now I've effectively combined the unicorns and the dragons. And then the same thing happens with Phoenix. Now, you don't have to make this crazy thing to do that. There's actually a more readable way to do it. If you just use the same logic of combining by index based on whether it's even or odd, you can just make a new array up here that's empty. You can go through each with the index, and you can just shovel in the evens and add the odds into your array up here. And that's probably something closer to what you guys have seen before. So I'll uncomment it so you get some highlighting there. But yeah, so the point of the story here is that there's multiple ways to do something. You don't have to try to put everything on one line. Honestly, this is more readable. So this is arguably better code. But if you get stuck with stuff like that, remember there's a bunch of ways to solve it. There's no one set way to do it, but you are going to have to do some finagling with your data when you scrape, because again, the person who made the website is not making it so that you can scrape information from it. We're kind of going behind the scenes here and doing it. Let's also take a second. So that's our filtering, right? So I effectively, at the end of the day, I have 4 arrays, right? I have an array of wand woods and an array of wand wood descriptions, and then an array of wand cores and wand core descriptions. Let's take a look at what happens if we don't know how to use CSS selectors quite as well. Well, it turns out that all is not lost, because all you have to do is when you go here and you see that, okay, these are all H2s that hold my woods or hold my cores, I can just actually grab all of the H2s, and then I can look at them. Here, let's take a look at them and see what it looks like. All right, so if we look at it, we're still getting all our woods, but we have J.K. Rowling in the front and we have find us on in the end. We don't want that. So we can actually just say like, let's put this out here to see what it looks like. We can just say, okay, give me wood types and give me index 1 all the way to the last one, right? Or the second to last one. So that'll effectively take out J.K. Rowling and find us on. So as you can see now, I'm ending with you and I'm starting with Acadia, right? So even if you're not like super comfortable with doing a more advanced CSS selector like you see here, there are ways to get what you need to get just by using plain old Ruby. And then a slightly less elegant way to do it too is just by making the 0th and the last one nil and then compacting it, right? So you can be creative. There is a bunch of ways to get rid of stuff you don't want. So just be creative. And again, like just as a third example, you could just pop and shift it, take off the first, take off the last, and now you end up with wood types, right? So again, I don't want to say it's better, but preferably you'll use nicer CSS selectors so you don't have to do any of that. But at the end of the day, if you need to, definitely use plain old Ruby to just filter what you need. All right, cool. Let's move on. All right, so this is where things get fun. We're now transforming the data. This is where we are no longer the spy that is retrieving information from the website. We are now the architect, and we're engineering this really, really cool ecosystem of Ruby objects that we want to use in our application, right? So this is where it gets fun. And I'm about to show you guys the way I did it, and hopefully it gives you a little window into some really cool ways that you can make objects relate with each other that make your programs act really, really elegantly. So again, so depending on the complexity of what you're scraping, this could be a very, very simple thing. Like if we're just trying to scrape Fandango and make movies, then we'll just need a movie class, and then we'll make movies from the information. Pretty simple. Our case here is a little bit more complex because we have a bunch of components that need to go together to make a bigger thing, and we need to make random versions of it. So there's a little bit more going on here. At the end of the day, what you have to remember is that there's no one set way to code it, right? You're the person in charge of your program. You're the engineer of the ecosystem. Make it however you want, and there's no right or wrong answer given that your application works correctly. That being said, try to push your limits in terms of like elegance and writing good clean code, because it just putting that little bit of effort in now really will build on itself and help you become better programmers in the future. Okay, so anyway, so when I scrape this information, I'm going to be getting, in our case, woods and cores, and I want to make those into classes, and we're going to call these classes models. And this is based off of a design pattern called a model view controller system, which I just want to get that little phrase out there. We're not going to be using it so much yet, but we will in the future. It's a way of organizing our applications and keeping different things separate, like our model and our view and our controller. But the big thing to remember is the information, the classes you make to hold your information are going to be called models. So let's look at transformation. So this is where things get a little bit complex, but also very fun. All right, so I'm going to start from scratch here, right? So I'm going to require OpenURI, no Kagiri, and also this little thing that I'm going to talk about in a second. And I'm going to harvest, and I'm going to filter. And if you take a look at it, there's a lot less lines of code than we looked at before. When I finally figure out what works, take out all of those put statements, it turns out I can harvest and filter things in just a few lines of code. Like this is what, 7 lines of code right here? Another 7 here, right? So 14 lines of code, and I've grabbed all of the information I need. So now the question is, how do I make an object ecosystem that allows the rest of my project to be a lot easier to write? So let's think about how I want to do this. First of all, I know I have woods and cores. Let me do a time check real quick. We're at 8:39. Are we over already? When did we start this? Time check, anybody?
We started at 8.
Okay, so we're good. Awesome. Whew, I got nervous. All right, so we have woods and cores, which are very similar because they're both components of a wand, and they both have a name and a description. So that should make a light go off my head and be like, hey, maybe I should use inheritance for this, right? So it turns out that they share a lot of stuff. Specifically, the fact that we want to initialize with a name and a description, they should have those instance variables. And I also want to keep track of all of them, because ideally, I'm going to scrape this information, turn them into classes, and then have access to all of those classes so I can randomly select, which ones I want and make random wands from them. So if you look at this, my wood and core classes are actually pretty simple, i.e. empty, because I'm writing everything I need in my wand component. So I'm writing it once instead of twice is really what's happening here. And let's take a look at what I write. So this part's super simple. I'm making a name and description reader, and I'm allowing my objects to be initialized with the name and description, making the appropriate instance variables, and then allowing the class itself to keep track of whatever was just the object that was just initialized. Now let's take a look at the class. Now this is a little bit more complex because my class is no longer just worried about itself. It's got these 2 subclasses that are both going to be initialized via this initializer. So it turns out this all array is going to be holding both woods and cores. So I now have to make that work. So The ideal thing, because I want to take random woods and random cores and put them into a wand, it'd be really nice to have a class method called rand. So I can just say like wood.rand or core.rand and just get a random wood or core object. Sound good? So what I want to do is take my all array, select only the things in the all array that are an instance of self, and then call .sample, which just takes a random sample from that array. Now what's happening here? Well, if I call wood.rand, it turns out that in my rand method, self is not wand component. Self is actually wood because I called wood.rand. So if I take this add all array and I call select on it, and I only select things that is a wood, I'm only going to get wood at the end of the day. So it's almost as if wood had its own add all and core had its own add all, because I'm selecting it down. I'm filtering it down to just the woods and the cores, depending on which one I call it on, because that's what self is going to be. And that's a really cool use of self in the context of inheritance. And this is one thing that makes inheritance really powerful, because now a superclass of wand component can tell which subclass called its own method. Do you guys see how that works?
Yeah, I have a question though.
Yeah, what's up?
You're saying the add all array is going to have both wood and core components within it.
Mm-hmm.
Why is that? When we inherit the wand component stuff into the wood and the cores, shouldn't the add all be class dependent?
So it would be nice, I guess, but that's not how, unfortunately, that's not how inheritance works in this case. And the reason is because I'm actually physically defining add all inside of wand component. And I think the reason that it doesn't do that is because there are cases where you would want a superclass. So really this holds all of the wand components. And it turns out that both of these are wand components.
So if you called an add all within each wand component class, could you then simplify self.rand?
If I said puts add all here, I would get woods and cores. Is that what you're asking me?
No, I'm asking you if you defined add all equals empty array.
Yes. Yes. If I said add all equals here, right? And then I didn't do it here, then you're right. I wouldn't need to do the select thing.
Okay, cool.
And that's a viable way to do it, honestly. That's just a design choice, right? So remember, as the programmer, you're the god of the universe. If you want to do the add all in here, that's a perfectly acceptable way to do it. It's just I was
trying to wrap my head around why it wasn't staying within the class.
Yeah, and that's why I did it this way, because I wanted to show you some of the intricacies of inheritance and some of the gotchas things. And that's one of the gotchas, is that if you do something like this, you're actually need to take an extra step to make sure you only get what you want. Make sense?
Yep, I'm good.
Awesome. Cool. So the last thing I want this class to be able to do is to mass assign objects. So if you remember correctly, when I finish filtering, I have these 4 arrays, and the arrays are lined up numerically so that the descriptions and names line up. So I have this set of rules that describe how I'm going to get data back. And instead of looping through and instantiating them myself, what if I just made a method that did it for me, and I could just pass in the array of names and the array of descriptions? That would be ideal, right? Because in the future, I don't want to have to keep looping in my application, every time I scrape. I want to just call a method, and again, this is abstraction. I'm abstracting away mass assigning and transforming everything into objects. I'm abstracting that away with this method. So what I'm going to do is I'm going to write a method, a class method in one component that accepts an array of names and descriptions. I'm going to raise an error if the lengths aren't equal, because if the lengths of those arrays are not equal, I know they can't be one-to-one lined up. So that will kind of give me a heads up if Pottermore changes their website and I start getting stuff I don't expect to get. This will give me a heads up, because I'm going to start instead of getting like unreliable results without me knowing about it, my application will crash, and then I'll be able to say, hey, this argument error is now hitting, so now I know I need to like go back to that website and figure out why that's happening, instead of this error not happening, and then I have like you lined up with like join us now at Pottermore.com, which is clearly not a description of you, and then I don't notice it because you only comes up when I call .rand, right? So that's why you want to use errors. That's a good time to use errors. And then and now what I do is I just take the names, I do each.index, because remember my indices are going to line up between names and description. and I just say self.new, and I pass in name and then the associated index of descriptions, and that'll be the one-to-one lineup between name and descriptions, and then that will mass assign all of my wand components, woods or cores. Awesome. Now, I want to make a wand, and a wand needs a wood, a core, and a length. This one's relatively simple. It's just a standalone class, no inheritance, no nothing. I accept wood, core, length. I have my readers for all three. Now, the little magic I have in here is overriding the 2s. So if I override 2s is built into every object. And normally, if you guys have accidentally printed out an object before, you see the little tags, and then you'll see, if it was a human class, for example, you'd see human, colon, and then this little serial number. Well, I don't want a wand to look like that. So I'm going to override my 2s method. So whenever I print out a wand, whenever if I put it in the hash in the squirrely brackets, or if I say .2s on it, I'm actually going to print out this string that says wood name, core, and then length inches. So for example, it would be like, I don't know, what are some woods? So like oak, I don't know if there are any oak, like oak, dragon heartstring core, 12.5 inches, right? So that's how I want it to be printed out. And then opposed to descriptions, so now I want to be able to say description, and I can now use the fact that I've overwritten my 2s method by just, see how I can just say self in here? This will print out the description. If I just put self in there, because when I put anything inside, when I put an object inside of these, this interpolation syntax, it implicitly calls 2s on it, which I have overwritten to be this phrase. So I can now say put self, it puts out my little description here, and then it puts out the wood name, the wood description, the core name, and the core description. So it gives a nice little outline of what this wand is. Cool. So now I have a wand, and I have my wand components. But that's really not the end of the day, right? Because at the end of the day, I want to be able to easily make random wands. So actually, before I get into that, let's talk about wand length. So we know that wands want to be between 9 and 14 inches. I've shown you guys the my little Gaussian generator class before. So I'm going to use inheritance one more time. I'm going to inherit, I'm going to have my wand length strategy inherit from Gaussian generator. And then I'm going to specify a mean. All right, let's talk about super actually. So my Gaussian generator has initialized which accepts a mean and a standard deviation. However, I know that all my wands should be between 9 and 14 inches. So in order for 95% of all wands to be between 9 and 14 inches, which is a pretty good distribution, I think, I'm going to make my mean 11.5 and my standard deviation of 1.25, because that's 2 standard deviations from the mean. All 95% of all my data will be inside of there. So a wand length strategy shouldn't accept a mean and standard deviation, because all wand lengths should be from the same random distribution. So what I can do is overwrite my Gaussian generator initialize method, not accept any arguments, call super, and pass in the arguments I want to be passed in. Super will call the superclasses initialize method. Well, really it calls whatever method you're in. We're in initialize right now, so it'll call the superclasses initialize method, and we'll pass in the mean and standard deviation. And then I'm going to also override my rand method, and this is polymorphism, which we talked about before. So now I'm going to override my rand method. My rand returns the random number, which is great, but it takes it to like 10 decimal places. I don't want that. I want it to 1 decimal place. So I'm going to return super.round pass in 1. Super calls my superclasses rand, and then I'm just going to round whatever it is to 1. So here's a really cool way of, again, using inheritance to make this cool little strategy based off of something I've already written, and make it use polymorphism to make it work the way I want it to work. All right, last little class here, wand factory. Again, I want to make a bunch of random wands. So instead of having to make a bunch of random wands in my application, I'm going to make a class that is a wand factory that makes them for me. So it turns out the factory is not just a little Micah shoot creation here. This is actually kind of an advanced topic, as is strategy. It's called object-oriented design patterns, and it's really, really cool to start thinking about it now. A factory is a pattern which initializes other classes for you, which is what I want to do here, right? I want to make new random wands. So instead of doing that in my application, I'm going to make a make wand method, which does it for me. A strategy is another thing I can use. It's another design pattern, and it makes it really flexible. So my length generator is taking in this wand length strategy we just talked about. Now, what if later I want to change up how my wand length strategy works? What if I just want an even distribution from 9 to 14 inches and only between 9 and 14 inches. Or I just want every wand to be 12 inches. All I have to do is make another class that has a method rand and pass it in as an argument right here. Because all I'm doing is saving this to an instance variable and calling .rand on it. So that makes my code way more flexible. And this is what I'm talking about like cool ecosystem design. This makes my code way more flexible because if I ever want to change up the way I choose a random wand length, that's all I have to do. I don't have to change anything else. I just need to write a new class, and I don't even need to change the wand factory. I just pass it in as a because this right now has a default argument here. So all I do is just pass it in as an argument, and now I have a new strategy. All the strategy has to be able to do is be able to call .rand on it, and it will work completely fine. So my wand factory gets initialized. I have a default thing in here, which is the strategy I want to use, so I don't have to pass anything in there. And now to make a wand, it just returns a new wand. And because I made my wood and core have this rand method, which samples a random thing from @all, instantiating a new wand is super easy. I say wood.rand, core.rand, and then @lengthgen.rand. And there I have a random wood object, a random core object, both from the scraping data I got, and now I have my length generator random number. So now I've really done a really cool, like, I put a little bit more time into making classes, made a little bit, maybe more classes than you would think would be necessary, but they're relatively short and they work together insanely well to the point where all I need to do at the end of the day, once I have my scraping information, is mass assign, create a new factory, and then every time I want a new wand, I just say factory.makewand. So let's take a look at how this works. And let's I don't know if I have any put statements in here. Let's get rid of those. Looks like I don't. Awesome. So let's run this. My wand. So let's say my wand.2s. You see, I overrode my 2s method. So now when I say .2s on it, you dragon core 11.8 inches. My wand description. Here we go. You dragon core 11.8 inches. You gives me all the information about you. Dragon, all the information about dragon core. I can exit out and run it again. I'll have a whole new wand. Walnut, Phoenix core, 13 inches. There we go. Right? So now I've taken my scrape data and I've transformed it into this ecosystem of classes that works super well together and works for me at the end of the day, because every time I want a new core, I just say factory.makewand. There's my new wand. This one is Ash Dragon Core 10.9 inches. Right? Here's a new one. Right? Ebony, Phoenix Core, 10.3 inches. So how easy is that to use, right? So that's why the transform step is super awesome, because you get to be very, very creative and kind of put on your architect hat and make really, really cool ecosystems of objects. I don't want to spend too much time on this because really at the end of the day, this is supposed to be about scraping, but I wanted to show you guys that. All right, so let's get back into it. All right. We already talked about this. We just want to make our ecosystem as flexible as possible, and we want it to work really, really well together. All right, so the last step is our utilization step. I kind of want to keep this for later because we're going to have another study group talking about how to make a CLI application, and this last part's really about modifying everything I have right now and turning it into a proper CLI application. So I don't think that's really necessary to go over right now. As usual, I expected this to take way shorter than it actually took, and we're nearing the end of our time, and there's something else I want to go over. So let's try to do some live scraping of Fandango. I don't think we're going to get through it, but I think it'll be fun. So all of you guys and I are going to now work on scraping Fandango. So what I'm going to do is I want you guys to unmute yourselves. And I want you to work with me here. And for the next 10-ish minutes, we're going to see if we can scrape Fandango. Sound good?
Yep.
All right, cool. So the starting point I want to do is let's do movies in theaters. So if I go to the movies in theaters, I get this nice little now playing list. All right, so what's our first step? If I want to get now playing, what's our first step?
Look at the HTML.
Okay.
Require URI, open URI, and
All right.
require Nokogiri. Because
All right.
we're going to end up using Nokogiri as well.
Awesome. All right, so let's do this. Let's start with, let me click on now playing. Let's inspect there. All right, so here's my now playing H2 element right here. See that? And it looks like I have a UL. UL stands for unordered list. And it looks like inside of my unordered list, I have a bunch of LI, which stands for list items. What is each list item? What do you guys, do you see what's being highlighted every time I switch it?
Yeah, the movies.
Yeah,
It's
looks like,
probably an image.
yeah, well, let's look inside of it. So it looks like there's a link to movie overview. It looks like there's an image, like you said,
With the source, yeah.
and another div. And inside of that div, there's another link. And it looks like it has the title, this text in there. So it looks like there's some information in there that I can use. Now, really all I'm going to get from this is like a link to more information, the name and the image link, but that's enough for now. So let's say that's all we really want in our movie class. So what's the next step?
We want to open URL or put a variable equals open URL and pass it the URL for Fandango so it can go grab this information or know where to look.
All right. So I had to put in the URL for Fandango. So how do I get that? What URL do I want?
Fandango.
You want to use https fandango.com movies and theaters.
This guy right here?
Yeah.
All right, cool. Let's do it. And let's set it equal to a local variable just in case I want to use it again, right? And you're telling me that you want me to say this right here?
That's exactly right.
I like it. What's this going to return?
It's going to open that URL.
Yep. And what kind of data does it return? Anybody remember?
HTML file or
Yeah.
XML file.
Yeah, like a temp file, right? It's going to return a
Yeah.
file class. So you remember how to make it turn into string? A string?
2s.
No, not
Dot-
quite.
No.
Read.
Dot read.
Yeah,
dot
dot read. Nice. I should have waited a second longer. You had it. All right. Perfect. Dot read. Exactly. All right. So now I have. So really, we finished our harvesting step already. We have our HTML, and let's make sure. So the first thing we always want to do is before we go too far, we just want to make sure that it actually
Is gathering the
is actually
data.
getting it right. So let's say Ruby Fandango. All right, so that looks promising. I'd say that our HTML is probably there. What do you guys think?
Yep.
All
Yeah.
right, cool.
Somewhere in there.
All right. So what do we do now?
We want to use Nokogiri to parse it out into an array, or is it a hash? A hash.
Do you
I
guys
don't know.
remember
What's our end goal?
our end goal? Oh, that's a great question. What do you want the end goal to be?
I believe we're gonna scrape the movies that are in theaters now, right?
You want
We
it?
just want a list of those movies.
I don't know. What do you guys think? If you were making a project, so again, what are the basic steps, right? Harvest, filter, transform.
So now we have to filter because we already harvested. We already have our raw data, and now we have to parse it out, right?
Okay. How do we do it? Anybody remember?
Do the Nokogiri : HTML.
You're
Someone else
almost-
help.
You're almost there. You got-
I don't remember either, Renee. I'm sorry.
How about that? Put in our text.
Yeah, that
Yeah.
sounds right.
I like it. So let's see what we got here. Let's again, every step, let's just check. See what happens. Let's say .class. Actually, let's not even say .class. Just see what that looks like.
That's taking a long time, Mike. I don't like that.
Looks like it looks pretty good. To me. If you notice, there's like no /ns in this one. It looks like it's a lot more. It looks like it's a lot more formatted, which gives me a good idea that it's the Nokogiri class. And if I want to be completely sure, I can just say .class at the end of the day here, and we should see, yep, Nokogiri HTML document. Perfect. Awesome job, guys. So now we have our parsed HTML. So now we begin our real filtering. So now this is where we kind of come back here, and we figure out, how do I turn this into what I want? So what do I want? Let's identify what we want.
Oh,
I
you
want the
want
movie title.
Title, I agree. Title is a good thing. So let's do some pseudocode. We want the title. What else do we want?
You want to click this thing to see what's in there, right? In each one.
Yeah, let's put the URL in there to get more data. Now, in reality, what I would expect you guys to do if this was your project is once you got this URL, to then have your program actually go to that URL and then scrape more information about it here, because you can get the rating, the length, the genre, you can get a preview link, and if you're really good, you can figure out how to get this information. But that's super tough, because if you
And
look
we have
at
to
it,
go to another website.
not necessarily, well, kind of. We'll talk about that in a second. But that is something that you think of. When you get a URL, you can now then use scraping to go to that URL and get more information, which is pretty cool. So anyway, let's just say we want the title, and let's say we want the more info URL, and let's say we want, how about, let's say the image path, right? So we can get the image link. How's that?
Okay.
You guys agree? Good set of data to get there? Cool. So how do we get it? What delineates this information, all these movies, under now playing? And I'll close this up so it might be a little bit easier to see.
The visual list, movie list class.
That is correct. However, I'll counter that point with, oh, actually, that's a good point. Let's see if they have it in here. Oh, visual list, movie list, class. Bummer. So it's good, but it's not good enough. Now, unfortunately, this number of opening this week will change, so you can't just take out the first, 4 or 5. So what's another thing that we can do? And this might be a little bit cheating because I don't think we covered it. So if you guys don't know, I'll show you what to do, because it's a little bit tricksy. But if you can tell me in English, then that's a good starting point. So what's a way to kind of identify, like, what about this web page can let us identify just these movies down here?
The now playing header.
Okay, so they're all going to be under now playing. What else?
H2 class, heading style 1, section header line. And
Okay.
the text from there.
Well, if you look at this guy, though, it's got the same class. So really what different is that this says now playing
now
and this
playing.
says opening this week. See that? That's the big difference. So it looks like we want to go under the H2 class now playing, and we want to then go into the unordered list, visual list, movie list. And we want to grab stuff from each LI in there. Does that sound good?
I'm sorry, can you repeat that real quick?
So what we want to do is we want to, oh, I just closed it out. Hold on one second. Oh, yeah, opening this week. No, that's not what we want. Where did
No,
the
it's the next one down.
Hold up. There we go. Okay, now playing. So we'll go into our unordered list, right? So we want to we want to get the UL underneath of now playing, and we want to get all the LIs inside of that UL. And then we want to, from there, we want to get each individual thing, right? So the title, and then the more info URL and the image SRC.
And we're just using the now playing as a reference point for this is the things we want to get.
Yep, exactly. So
Got
remember in the example how I said P and then squiggly H2, or I said H2
Mhm.
squiggly P to get all the P's right after that H2?
Yeah.
So we can do the same type of thing here, where we can identify the H2 that says now playing, and then use the squiggly to get the UL after that. And then we can
Got it.
use the nesting to get all the LIs inside of that UL. And each LI will be a movie. So what we want to do now, before we start worried about getting titles and more info, we want to take our page, our parse HTML page, and we want to turn it into movie LIs. That seems like a good intermediary step. What do you guys think?
Mm-hmm.
All right, so let's say parsed HTML.css, and we said we want to get the H2 that has now playing in there. So I'm going to show you guys how to do that. So we're going to say H2 colon contains, and we're going to say, here, let me put, so because I need to use quotes now, I need to make sure I use different quotes on the outside than I do on the inside. So I'm going to use double quotes on the outside and use single quotes on the inside to say now playing. So right now in my CSS selector, I've said, get me an H2 that contains, and again, this is all, I didn't know this when I made this. I Googled it. So that's what you guys got to do. When you're like, the first step is saying, hey, I want to get this H2 that says now playing. Is there any way to do that? It turns out that 5 minutes of Google searching told me how to do that, even though I had no idea how to do it when I started, right? Because I don't scrape that often. So and you guys are just starting, so you're not going to know how to do stuff. So Googling is got to be a good skill that you guys have at this point, or at least build up. So I say H2, I say contains, and then I put in my text now playing. And notice how I'm using double quotes on the outside, single quotes on the inside. Because if I didn't do that, I would be now ending this string, and now this Ruby would think this would be a variable, but it's not, right? So I need to use different types of quotes.
Okay,
And
this
now,
is a goofy question.
what's up?
But if I needed to nest like 6 quotes for some reason, for some ungodly reason, could I just keep alternating quote types, or is there a way to do that?
Yeah, you should be able to escape. So if you do slash, see that? I've now escaped that. Yep.
Okay, cool. Thank you.
There's also another thing. If you want to, after this, just go ahead and Google %w in Ruby, and that shows you a way to kind of make an array of strings that might be helpful. Actually, there's a different one. I'll get back to you on that.
No worries. I didn't
I'll
mean to
shoot you a
derail
slide.
you.
No, you're fine. So now I've got my H2, and I said before, okay, well, I want to get my UL that's right after that H2. So we know that the squiggly tells me something that's afterwards. So I'm going to say UL, but I want to be very specific. Because,
can you zoom your text real quick a little bit?
Oh, yeah. Sorry.
Editor. Oh, cool. I can read the thing now.
Awesome. Sorry about that, guys. All right, cool. Is that good for everybody?
Yep.
All
Thank
right,
you.
so, yeah, no problem. So, and let me put this over too. All right, sweet. So now I'm saying, okay, after that H2 is now playing, I'm going to get my UL. And let's be very specific, because I like to be specific when I can. That UL has a class of visual list and another class of movie list. So I'm going to say ul.visuallist.movie list. That's saying the UL after this H2, which contains now playing, has to have a visual list class and a movie list class. Okay? And then now I'm at the point where I've gotten my H2, I've gotten my UL, and now I want, remember, at the end of the day, I want the movie LIs. So now I have this UL, so now I can just use the descendants of it, so all the things inside of it, and I want LIs that have the class visual item, right? Because every single movie has visual item as a class. So now I have finally made my CSS selector that starts off at my H2, which contains now playing. I've got the UL right after it. And then I put my space to say, okay, now I want stuff inside of that UL. And I specified li.visualItem right here. So this ends up being my selector, and I get each li. Do you guys all follow that? And kind of the process we took to just kind of have our code open, have the web page open, and just take a look and figure out how to get that? Does that make sense to you guys?
It's going to take a lot of practice.
It really not practice, a lot of Google, even when I was doing this, right? So the third step is having this open and being like, CSS selector. Okay, so that's something I typed yesterday, clearly, right? So CSS, let's say get adjacent, right? Get adjacent. Right, so now we have this, right? So you can also get adjacent, looks like with a plus. So we could probably use a plus here to get the adjacent one, right? So that's how this works. Is you go on Google, you have to know how to say this so you're getting the correct thing. You don't want to say, if I am making a CLI app for a flat iron, so like that's not effective Googling, right? Obviously that's like a hyperbole to what you guys would actually be doing. But the point is you want to be like very, very specific and to the point, and you want to use Google effectively. So again, when I did this, I looked at this, I said, okay, I want my H2 that says now playing, I want the UL next to it, and I want the LIs underneath that. So I got on Google and I started with this. How do I get the H2 that has the now playing text? Well, I found this. So I tried that, and then I pushed it out and see if I got that H2 element. I did. So it's like, okay, well, how do I get the UL next to it? And I Googled that. I found this little squiggly guy, and then I tried it, and guess what? I had an array with one thing in it, and it was this UL. Then I said, okay, I want all my LIs now. So I know that I knew already, this one I did know, that if you do a space and then whatever you want, you get all the things inside of it. So I put my space, I put my li.visualItem because my class is visual item. I pushed it out, and guess what? I got all my LIs. So that's the process. The process is doing one at a time. So let's try that actually.
You're missing a T.
Where?
Oh no, it's movie list. Never mind.
Yeah, it wasn't supposed to be list. It's supposed to be LIs.
I got
Plural of LIs. So this would be step one, right? H2 contains now playing. Now I'm getting my H2 class. So that's my starting point. So now my next thing is saying, okay, well, now I want to see if I can get that UL. So I type in my squiggly UL. Actually, let's try plus, see if that works. My adjacent UL, because we just Googled that and found it. Let's see if that works. So that didn't work. Well, maybe it's because I have a space here. Let's try deleting that space and see if that works. All right, so that did work, right? So now I have that UL, and look at all those LIs in there. See, Forbidden Planet. So I'm seeing movie names in there. So I'm assuming that that's the LI I want. So now let's say, okay, so I have my H2 that contains. I Googled how to get the adjacent thing with a plus. I used it. And now I'm getting my UL, visual list, movie list. And then inside of that UL, I want all the LIs. So I do a space. And I say li.visual item, because that's the class name. And now let's put that out and see what we get. And it looks like I'm getting all these LIs, and see Westworld. So I get the A's. I'm getting that the movie overview link that I remember seeing before. So this is a pretty good indication that I'm getting what I want. I'm getting the names again, movie overview, image with the SRC. That's the exact structure that we saw when we opened it up, right? So okay, so now I have all my movie LIs. So we're running a little bit over, so we're not going to do the whole thing, but we want to now take this and turn it into a name, a URL, and a SRC for our image, and then we'll call it a day. We won't turn it into classes today, but if you guys want to go over that, just contact me. If you guys want to organize your own little impromptu study group, I'll hop on and I can do that for you. Okay. All right. So yeah, so let's go ahead and do that. So what's a way I can take these LIs and turn them into just the data I want using a nice Ruby method that maps stuff to other stuff?
Can you use each?
I could use each, but what's something where I can like actually transform something?
Map or collect?
Yeah, let's use map or collect. Each would work, but remember I'd have to say like my array here and then do each, right? But it'd be better if I could just do so we want the title, we want the image, and we want the more info URL. So let's call this title image URL, and let's say movie lis.map. All right. So now the question is, what do I want to map it to? Well, at the end of the day, whatever I map it to is just going to be used to instantiate new objects. So really what I want to map it to is something I can use later. So I have a few options. I can map it to an array with 3 elements, and I just know that it's going to be the title and then the all right, let's do this. And then the image link, and then the info URL, right? Or I could make a little hash where this could be the keys, right? So it doesn't matter. I kind of like the idea of a hash, right? So let's make it into a Yeah, actually, no, let's just do an array. Screw it. It really doesn't matter. What do you guys want to do? Hash your array. Your call.
Hash it.
Hash it.
Hash it.
All right, cool.
Just because you backed away from it.
How do I get the title? Where does the title live?
Under LI visual item.
Yeah, well, remember, each LI here is going to be a visual item because that's the last thing I said here.
Oh, yeah.
This will be an array of LI visual items. So now when I say LI here, I'm dealing with a single Nokogiri LI, which is super cool. So now where does my title live?
Under
Yeah.
div.
Okay.
Visual detail.
All right, so let's open it up here as we type it out. So let's start out by saying li.css because we want to do more CSS selectors, right? So we're saying div.visual detail. Okay, so let's open up visual detail. All right, now where is it?
The link, visual
A-
title.
Okay. Inside of the link. And it's the text inside of that link. And there's only one link there. So this is one case where I'm okay with not being as explicit. There's only one link in there. Let's just say space A. Inside of this div, visual detail, I have a link. So I'm going to say space A.
Dot
And then-
text.
Exactly. Dot text. But notice all this white space. How do I get rid of this white space?
Dot strip.
I like it. All right. Actually, let's start with this. And let's just, let's see what this looks like. Actually, let's clear first. Look at that.
Cool.
Aladdin 2019. Right? Look at that. John Wick, chapter 3. Right? Awesome. And the last little bit's going to be super simple. I'm just going to get the image, and I'm going to get the info or the URL, let's call it. And then, so how do I get the image? Where does that image live?
Source href. Image.source. Where is it? There it is. It's under the A class image.
It's the only image though, right?
Right.
So I can just grab image at this point. So what do I
Just
type?
IMG.
Yeah.
IMG.
So what do I type? Tell me what to type here.
Div a.img. Div.a, sorry, .img.
I mean, don't you need to call CSS selectors on
Yes.
this still?
Exactly. You need to say. So,
li.css.
I didn't want you. You're getting too much tunnel vision, so I was going after that. So exactly. So we still have to deal with this li right here. Exactly. So what do I say here?
Div dot.
A, or wait, do we zoom directly
No,
into
you have
the?
to call its visual container, right? Div
Yeah.
dot visual container and then space A.
Is that a div?
Oh
Visual
no, I'm
container?
sorry. It's
A.
not.
It's A.
Now what?
And then
IMG.
close it out, right? And then call image.
You got to do .img.
You want that?
No, after the
I don't know.
container.
Is that right?
I don't know. Let's find out. What do you want me to type? You tell me what to type. We're going to test it.
.img.
Right here?
My
Right after
instinct
the
is
container.
after the close because that's where we put dot text. That's why it's my instinct.
All right. Let's do it. Let's see what happens.
Well, the comma. Oh, because you have a comma there after the img.
But
Well,
they
that's
have,
just to delineate that it's a new
Oh, yeah,
path.
yeah.
so I would say after container, we do just like we did A, and we just do.
It's space IMG.
Mm-hmm.
Undefined method image for Nokogiri. So there's no image method that we can do here.
Right. So after the container, inside the single quotation, you should do just IMG.
Right here?
Yeah.
Okay. Let's see what that looks like. So it looks good, but it looks like I'm getting this Nokogiri, this array of Nokogiri elements, or at least array of single Nokogiri element. So there's a single image,
Is
and
it dot source,
dot source
like img dot src?
right here.
Yeah.
There's the images.
No, because that would mean that the image would need to have a class.
So maybe
It-
you just src instead of image.
No, that's not going to work either. I'm going to show you guys what to do here. So first of all, we can actually just say image right here instead of going down, because there's only one image. So see how we still get that array of Nokogiri elements. And then if we want to grab that src, what we can do is we can say, first of all, if you notice, it's an array, right? So the first thing we need to do, we know there's only one in there because there's only one image per li. So we need to, first of all, just get the image itself instead of an array of image. So we'll say dot first. And then we're going to say dot attribute, and then we're going to say src.
Mm.
You guys are all like that makes a lot of sense, but I don't know what any of those things are.
I'm like, this is completely. That was new.
I don't know what
You guys know the
But-
dot
what-
source.
Yeah, but what is SRC? And what is the
SRC
attribute
Source is right
for?
there. It's image source. That's your tag for whenever you have an image.
And
You
if
have
you-
to have a source for it.
So what we're actually calling, what we're returning, what we're putting in as image is the link to the image.
Yes, exactly.
Okay.
Yep. Sorry if that wasn't clear. Yeah. And so if you see right here, so there are attributes, and one of the attributes, as you can see right here, is src. And the reason that we needed to get first, as I said, like, is because it's an array here. So that's something that's super, super easy to miss. It's one of those things you always have to be, because when I first did it, I missed it too, actually. So I was calling dot attribute src, and I was like, why isn't this working? Well, it's because I was being dumb, and I didn't check to make sure what type of data I was working with. That's why.
So we're just calling first, even though there's only one in that array, to get it out of the array.
Yep. So we don't have to call adder on an array, because we need to call
What-
it on the actual Nokogiri.
What does adder do?
It says attribute. So see where it's href is an attribute, src is an attribute.
Yeah.
So in order to get any of these things, you say dot attribute. And I wasn't expecting you guys to get this. Honestly, I was just trying to get you to say dot first, and then I would have showed you the attribute thing. But what you need to do in order to get any of these inside things like src or href is to call dot attr, dot attribute.
Okay.
And there are other ways to do it within Nokogiri as well, and that's like another Google thing. So just like Google it whenever you get to that point. I don't expect you to remember this. I expect you to remember like how we did this, and expect you to remember to use Google and kind of like be like, oh, that seems right, that doesn't seem right, but I don't expect you to remember all of this stuff. So this is more of like a process, showing you the process rather than remembering how to do it.
And we can just call image because there's only one image per li. So it's just going to
Exactly.
keep going through it until it finds an image.
Yeah, exactly. So the li itself, as you can see, it ends, it goes from here to here, and we know, hey,
Okay.
there's only one image there. So unless they change the website, we're good.
Right. Got it.
And then the URL itself. So it turns out that both A tags have the same URL. So I'm just going to do this one. You can just say li.css. We can grab the A tag. We can grab the first one, or we can use this. So same thing. And then attr, and then we're going to say href. Right?
Got it.
And then if we take a look at this, we're going to go ahead and see that now, once it's done, we have a title, an image URL, and then the URL for more information. And from here,
Yes.
and from here, what we do, and I can just actually I can show you my code for what I did from there. Is I put all of this code into a class called Movie Scraper, and said scrape now playing, and did what we just talked about. Made a class movie, had to have a name, image URL where it could be initialized to that. Made a little class method which mass assigned it from our hash or array, whatever we decided to do. So I guess I did a hash too, and I did it. I wasn't looking that far down. And then I made another little class called Movie Manager, just in case we wanted to do more than now playing. If we want to do like coming out, opening this week, we could just add that array to this, and then we could choose which set we wanted. So that's just like,
we could do that in a line at name, comma, at image, comma. I didn't know we could do it like that.
yep, you definitely can. And it's
One-
not all languages let you do that, but Ruby does.
Mm.
Awesome. All right, guys. Well, we're like or I think we're like half an hour over at this point. So so I'm gonna go. Hopefully you learned a lot about scraping. If you have any questions, definitely let me know. Hit me up, and we can talk about it. But have a good night. I'm gonna stop recording real quick.